Good morning, ladies and gentlemen. I hope that you had a good weekend, and I hope that you have had a productive day here working on your review for your test tomorrow. I actually am going to work out all of the problems on the review, and hopefully that will answer any questions that you have. You will be able to find this video link on Edline. Our first question asks us to isolate the x and x plus 4 is greater than 12. Our first step is going to be to subtract 4 from both sides. After we subtract 4, the x is isolated. We keep our greater than symbol, and 12 minus 4 is 8. In order to graph this, we are going to put a 0 on our number line, a positive 8, and a negative 8. We have a greater than symbol, not a greater than or equal to, so since it's just greater than, we're going to do an open circle. If we want to check 0, is 0 greater than 8? The answer to that is no, so we do not go towards 0, we go in the opposite direction. So we draw our arrow right here. Problem number 2. We still want to isolate our variable, which is x. It's kind of hard to see, so I'm just going to undo that. We are going to add 9 to both sides, which leaves us with 3x is less than or equal to negative 3. Divide both sides by 3, and we have x is less than or equal to negative 1. I hope that some of you are remembering we do have fireworks at times when we multiply and divide, but that is only when we multiply and divide by a negative. So far, we haven't done that. It is less than or equal to negative 1, so we have a closed circle. And if we want to check our 0, is 0 less than or equal to negative 1? No, it is not. 0 is greater than negative 1, so that doesn't work. We don't want the side with 0. We want to go in the opposite direction. Problem number 3. Let's see, we'll get another color. We are going to add 1 to both sides, still trying to isolate our x. That gives us 1/4 x is greater than 3. Ooh, I take that back. It's not greater than. 1/4 x is less than 3. Sorry about that. So now we have to get rid of this 1/4. There are a couple of ways to look at this. If we multiplied, we would actually have x divided by 4, and the opposite of divide by 4 is to multiply both sides by 4. Some of us are going to want to divide by 1/4, but keeping in mind when you divide by 1/4, if you put that in your calculator, you have to use parentheses. I want this fraction to go away, so I'm going to use my reciprocal. I'm going to multiply by 4 over 1. And when I multiply by 4 over 1, I have x is less than 12. So I'm going to show my 0, my 12, and my negative 12. I know it's not perfect, we're just doing a sketch. I have an open circle because it's less than. There's no equal to involved, it's just less than. And I'm going to check my 0. Is 0 less than 12? Yes, it is. So that means we are going to shade the side that includes 0. Going in this direction, There you go. Number 4, trying to isolate our m, trying to get the m all by itself. The first thing we're going to do is choose purple and subtract 8. When we subtract 8 from both sides, the negative 2m comes down, and it is less than or equal to 36 minus 8. 36 minus 8 is 28. After we subtract, we divide both sides by negative 2. And what happens? I hope all of you are seeing fireworks. When we divide by negative 2, that should catch your attention. And the beautiful ones that swirl everywhere, we have to do what? I hope you all just said flip the less than or equal to sign into greater than or equal to. 28 divided by negative 2 is negative 14. So now to graph, we have 0, we have 14, and we have negative 14. We have a closed circle on negative 14. That's very important because it is equal to, greater than or equal to. And if we plug in a 0, is 0 greater than or equal to negative 14? Why, yes it is. And so we are going to shade to the right. Now we're going to go to the next page. We have number 5, and we'll just keep the purple. Number 5 has variables on both sides. If we have variables on both sides, then we have to move them to the same side. This is a negative 4x. The opposite of minus 4x is to add 4x. So I'm actually going to do that. I'm going to add 4x to both sides. A negative 4x and a positive 4x cancel out, and they leave me with 9x minus 10 is greater than or equal to 17. I then add 10 to both sides, and I get 9x is greater than or equal to 27. Working out beautifully. If I divide both sides by 9, then we are going to have x is greater than or equal to 3. I do not have any fireworks because I did not divide by a negative. From here, and this is my fault, I'm going to need to draw a line, and it's not happy. There we go. We'll make it like the one that it was supposed to be. I took too much room in writing. We are going to have our 0, our positive 3, and our negative 3. It is greater than or equal to, so we have a closed circle. And if we check our 0, is 0 greater than or equal to 3? Not last time I checked. So we don't want the side with 0. We want to go greater than 3. 4 is greater than 3. 5 is greater than 3. 10 is greater than 3. They're all in this direction. Do we have any questions? I hope not. Too bad I can't answer them, but hopefully this is helping you get all of the right answers. And the good news is you can watch it one more time. For number 6, We still want that x by itself, even though it's on the right-hand side. We don't need to move the 7. The variable's on the right-hand side. We need to move everything away from it. So we're going to add 3 to both sides. And we get 10 is less than 5x. When we divide both sides by 5, we get 2 is less than x. Now, in graphing this is something that we've got to be careful with, because some of us are still doing the point thing, but if it's written this way, can we do that? We've got a 0, we've got a 2, and we've got a negative 2. If I check my 0, is 2 less than 0? Yeek. 2 is not less than 0. That doesn't work. So I do not go this way. I have an open circle on 2 because it's just less than, and I'm going to go to the right. Now I had one of my students, I can't remember who it was, did a good job of flipping this around. They changed this to x is greater than 2. So that lets us know that it does go to the right if our x is on the left-hand side. We have a couple more problems to go over. Number 7, if we are graphing our two-variable inequality, first we have to find our points. My slope is going to be 3, and if we write that as a fraction, it is 3 over 1. That means we are going to go up 3 and right 1. My y-intercept is 2, so I put a point on 2. I go up 1, 2, 3 over 1, up 1, 2, 3 over 1, down 1, 2, 3 to the left 1, down 1, 2, 3 and to the left 1. Because it's just greater than, I have a dotted line. And now I have to check my 0, 0. We don't have just one 0, we have to plug in 2 zeros. Is 0 greater than 3 times 0 plus 2? And that cancels out and tells us, is 0 greater than 2? No, so we don't want that side. We want to shade the opposite side. We want to shade greater than. So it's going to be over here. For number 8, we have a y-intercept of 1. We have a slope of negative 2. So if our slope is negative 2 over 1, that means we go down 2 and right 1. So down 2 over 1, down 2 over 1, down 2, right 1, sorry, up 2, left 1, up 2, left 1. It is a negative slope. It's an equal to, so this is a solid line. This one is a solid line. Sorry for my bad line. This one you want to remind yourself, greater than is just a dotted line. Please make sure on your test that I can tell the difference between a solid line and a dotted line. Over here, I've got to decide how to shade. So if I plug into 0, 0, is 0 less than or equal to negative 2 times 0 plus 1? Well, negative 2 times 0 is 0. So it goes away, and 0 is less than or equal to 1. That's true. So we are going to shade over here. Looks like Christmas. We have a few more problems, so I guess I'll be making another video in just a second. Let me get started again.